let's look at filters. So someone asked a question, how do we remove unwanted signal? So if you look at this block diagram, just revisiting this block diagram, you saw multiple places there is this filter, right? You can see there are so many filters in the system, right? So this is just a a representative block diagram. This is not an actual implementation, but actual implementation will be something very similar. Okay, so you see that there are multiple filters here, and this is also a filter, by the way. Okay. So all this, the whole purpose of the filter is to remove unwanted frequencies. Okay, so let's look at few basic filter types. So what is this filter? So this is a filter which allows all the frequencies up to FC. So it's a low pass filter. That means it allows frequencies starting from 0, let's say 0 hertz to FC hertz. Okay, example. This is a low pass filter. So what is this? This is a high pass filter. So it does not allow anything here, but it allows frequencies above FC. Then this is a band pass filter. So it allows frequencies within a band. So whatever you see here filters, mostly these are all band pass filters. So all the filters that you see in this block diagram, they are all band pass filters. Why band pass filters? Because if you remember, I told you that we have an allocated band. Okay, we have to work within this band. We cannot work outside that band. So that's why band pass filter is commonly used. Then this is a band stop. That means you don't allow frequencies within a particular band. So this is also sometimes useful. Sometimes we have some interfering signal, some interference, which is not required. Okay, maybe it is coming inside the receiver and it is jamming my LNA. It may damage my LNA. So I put a band stop filter if I know that interfering signal falls somewhere within this range. Okay, I put a filter. Okay, now the question is, we cannot implement these kind of theoretical implementation. See here, this is a flat, like a rectangle here, right? It's like a rectangle like this. So these are called as brick wall filters. Okay, brick wall. It looks like a brick, right? It's a pure, like a perfect rectangle. We can't implement filters like this. Okay, so the real filter will be something like this. So see, within the pass band, that means if you, this is an example of low pass filter. So see, this straight line here is actually not straight. It will be like this. So this is zoomed in version, but it will be like this. And this is not, this doesn't fall off exactly like this. So it falls off slowly like this. Okay. So this is a practical implementation. So if you ask me why it happens like this, this is how you can actually implement. Okay, the limitation is in the physics. It's not about design. You can design it in a computer, but you cannot really build a filter like that, which is very flat. Okay, it's going to be like this. There's an implementation limitation, and you cannot overcome that really. You can improve it, right? You can reduce this. You can reduce these variations, but you cannot make it zero. Okay, so what are the different ranges? So we already discussed about the bandwidth that time, right? That is the pass band. So we said that it could be 3 dB bandwidth or whatever you want to define. So that is this. And then there is a transition band. That means it doesn't fall off immediately. So it falls off slowly. So that is the transition band. And then there is pass band ripple. That means there will be some variations within the pass band. Similarly, there will be stop band ripples also. Okay, this is outside the band. So this is how a practical, let's say a filter, low pass filter will look like. Okay, let's look at, if you ask me how does a filter look like, it doesn't look any fancy. It just looks like a chip. If it's a PCB based filter, it looks like something like this. This is a vendor called Qorvo, Qorvo. So this is one of their band pass filters that you can see here. And this, the difference between this is another filter. Okay, so you can see here it is written Tao Glass. This is the vendor, and you can see it is a band pass filter, and you can see the frequency. It operates up to 2.4 gigahertz. Okay, this is another vendor. So what is the difference between this and this filter? If it's the same frequency, then the performance, should be very similar. Okay, the performance should be like a band pass filter. The performance is not compromised. What is the difference is you might have seen PCBs, right? PCB, like a board, printed circuit board. So this filter goes into that PCB. So you basically solder it on a PCB. Okay, and this kind of filters are external filters. So these, you don't solder it on a PCB. You can connect it to wires like RF cables. Externally, you can connect it. So these filters, you can remove it, you can put it whenever you want. But this kind of a filter, if you put it on a PCB, it's there. It's always there on the PCB. You cannot, if you remove it, then you have to put back again if you want it. So there is no flexibility here. Here you can remove and keep putting it. So that's the only difference. Otherwise, both are filters. Please click on like and subscribe to our channel, and click on the bell icon for regular updates.